Hello, geometry people! Today we are talking about the Pythagorean theorem, one of the most important things we talk about this entire year. The Pythagorean theorem is one of the most widely used geometry theorems outside of the classroom. Okay, so we need to make sure that we have this information down. You may have seen it before, hopefully you've seen it before, and hopefully the skill comes back to you and you remember some of this stuff, okay? So the little pencil right here on the screen tells you that you should write this part down. The Pythagorean theorem focuses on just right triangles, okay? And you should remember that right triangles have special names for their sides. You should write this part in your notes as well. Draw the little picture of the right triangle. We have a leg, we have another leg, and then that longest side over there across from the 90 degrees, over there, that is the hypotenuse. Okay, so we have two legs and a hypotenuse for every right triangle. And if you remember back from when you first heard about the Pythagorean theorem, you may have learned it as a squared plus b squared equals c squared, and you are correct. But you should also know that the Pythagorean theorem is about those three pieces and what each part represents in that formula. In symbols, or in understanding what we're talking about here, the Pythagorean theorem says if you take one leg on the right triangle, square it, add it to the other leg on the right triangle squared, it will equal the hypotenuse squared. And we will see tomorrow or in days to come why that comes about, why that is, and learn a little bit more about the history of it. But for right now, let's just recall how to work this formula a little bit. You probably recognize it as a squared plus b squared equals c squared. Remember that c always has to be the hypotenuse, okay? It's not always the x in the picture, but it is always the hypotenuse that's in our picture. So let's use that formula. Do not write this one down. And I just want to kind of see if you remember how this works. So if I have this triangle here, one side is a 4, one side is a 3, one side is an x, and I'm about to use the Pythagorean theorem, it helps me find a missing side of a right triangle. So if I was going to plug the numbers in there, 4 is on the leg, 3 is on the leg. So 4 and 3 will go in for A and B. X is the hypotenuse, so it's going to go in where the C is. And now I need to remember how to solve or simplify this and solve to get my answer. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. So 25 equals x squared. Now to get the x alone, I would square root, x equals, and we would put plus or minus 5. However, since we're talking about just a side of a right triangle here, the plus or minus is not necessary because you can't have a negative side of a triangle. So x would be 5 for us. So the missing side length of this triangle is 5. This one I need you to get in your notes. We'll do a couple in your notes and then we should be good here. So 6, 10, and x. If I was going to plug the numbers into the formula says a squared plus b squared equals c squared. And if I plug those numbers in, 6 and 10 and x, well, x is the hypotenuse because he's across from the 90 degrees. So the x has to go where the c is, and the a and b then are the 6 and the 10. And now I need to calculate this and simplify this. So 6 squared is 36, 100 or 10 squared is 100 equals x squared. X equals 136, and then we square root here to solve for x. So the square root of 136. Now we talked about how you cannot write decimals here for these values. Okay, no decimals. So we need to simplify that square root. What perfect square can divide out of 136? And you want to choose a big one if you can, but if not, we need to just find one. So if I go through my list, 136 is 4 times 34, and 4 is a perfect square. So if I square root the 4, I get a 2. Square root of 34 is what I'm going to leave alone. So x equals 2 square roots of 34. Okay, you will not be allowed to write decimals on your answers. You need to simplify your square roots. Okay, here's a second example. So, oops, I left a 90-degree box out of here. Draw that in when you write it into your notes. Draw your little triangle. And we have 8, x, and 15 on this triangle. And again, we're going to use the Pythagorean theorem to find a missing side of this right triangle. So looks like we have 8x and 15. We need to figure out where they all go. The 15 is the hypotenuse. He's across from the 90-degree corner. So with that in mind, the 15 has to go where the C is. And the 8 and the x go in for A and B. And now we need to solve this for x to find out that missing side. So 8 squared is 64. X squared, I don't know. 15 squared is 225. So if I take and I subtract the 64 now to get x squared alone. So 225 minus 64 is 161. And then I go ahead and square root that. So I have the square root of 161. Do any perfect squares divide out of 161 nicely? And the answer to that one is nope. So I would just leave him as 161 underneath the square root. Okay, so those are our two basic examples. Maybe you also remember this idea from earlier grades. I would write this part down as well. Sometimes we're asked to figure out if something's a Pythagorean triple. Using the Pythagorean theorem can help us find missing sides, but a Pythagorean triple is a set of 3 whole numbers, okay, whole numbers. That means no funny decimals. We're talking about 0, 1, 2, 3, 4, 5, normal whole numbers here, okay? No negatives, not integers, whole numbers that work in the Pythagorean theorem. So if I had this as a multiple choice question, you should write this part down. Which of the following is a Pythagorean triple? And you had that list to choose from. Is there one that you could eliminate right away based on that description of what a Pythagorean triple is? Yeah, hopefully you would go, hey, I'm going to eliminate A because this is not a whole number. Okay, after that, these 3 other choices, I need to decide, since they're whole numbers here, do they work in the Pythagorean theorem? So I need to test them. That means since 20 is the longest here, he would be the hypotenuse. I can plug them into the Pythagorean theorem and it makes sense. So if I do 9 squared plus 16 squared, is that equal to 20 squared? And I would go to my calculator and I would calculate that. I would figure it out. 9 squared is 81, 16 squared, okay, 9 squared plus 16 squared, that is 337. And then 20 squared is 400. So the answer to that one is no. That does not work, so he is not a Pythagorean triple. Let's keep going. 4 squared plus 4 squared, does that equal 16 squared? Nope, that one's not good either. How about 9 squared plus 12 squared equals 15 squared? Let's test it. 9 squared is 81, 12 squared 144. 81 plus 144, 225. Hey, that does equal 15 squared because 15 squared is 225. So this one is a set that we would call a Pythagorean triple. It's whole numbers that work when we plug it into the Pythagorean theorem. They would make a lovely right triangle. Okay, so that idea we need to make sure we have under control in our notes. And then this is the last one that goes in your notes. Now here is where our work in geometry is going to go eventually. We're going to need that Pythagorean theorem to find missing sides, to find areas, to find volumes later on. So here's just a basic triangle. Let's draw this one in our notes. It says to find the area of this triangle. So the area, if you remember area of a triangle, the formula is 1/2 base times height. If I look at this triangle and I go, okay, area equals 1/2, what's the base of this whole big blue triangle? 8 inches. Okay, what's the height of this beautiful blue triangle? The height is not 12. Height has to be from the bottom straight up like this. So I don't know that height yet, but I can use the Pythagorean theorem to help me figure it out. Because within the blue triangle, there is a right triangle. See them? And that allows me to calculate that height very easily. How long would it be down here on the bottom? 4, halfway across the whole 8 on the bottom. So I would set up the Pythagorean theorem to find that height. It would look something like this. 4 squared plus h squared equals 12 squared. The 12 is the hypotenuse because here's the 90-degree corner. He's across from him. Okay, so 4 squared is 16. H squared, don't know. 12 squared, 144. So the height squared would be 144 minus 16. 128. So if I square root the 128, then I would need to go ahead and try to break apart that square root. Okay, 128, does it divide by 4? Yep. But is there a bigger one? Because 4 and 32, 32 can also be divided by 4 again. I think we need to try a bigger one. What about 16? Yep, but maybe even bigger. Yep, if you were thinking it, 128 is 64 times 2. We need to use the biggest one we can so that we don't have to do as many steps. So the height of this triangle is 8 square roots of 2. And so now when I go up and I try to calculate this to find the area, here's what I would do. I'd write in that height that we just figured out, and remember our rules. All of these numbers that are outside the radical can get multiplied. 1/2 times 8 is 32. And then the square root of 2 stays as is. So the area is 32 square roots of 2 inches squared, because that's how we label area. And if you wanted to do a decimal approximation, we have to remember, because it's not perfect if we round with a decimal, we would type in 32 with a square root of 2 behind it, and roughly it is 45.3 square inches. Okay, so that is how we will use the Pythagorean theorem to come. It is going to be useful for us as we continue on our geometry journey. Thank you for taking good notes.